Hello and welcome back to the channel. And oops, this is where we left off. So now our wonderful hero can fall off and jump. But in today's episode, I'm gonna add another way for him to actually harm himself, and we'll design and add traps. And this is kind of interesting, at least I hope, because we have to take a good look at our, where is it, tile sheet, yes, and search for the parts that we can use as a traps. We have some spikes here and we have a nice block here. So what I'm going to do is I'm going to press Ctrl C and Ctrl V to move those out of a tile set, and here they are, and let me rename them. That's gonna be spikes small, spikes big, and actually let me be more specific and name it trap spikes. Trap spike small, and then that's gonna be call this trap center or trap block. Trap block is fine. Okay, so let us think about what we would expect from our trap. So some assumptions here. I would like my trap to have ability to move in Y or X axis and have spikes either on the sides or maybe on top, or maybe on top and on the sides. And then whenever user jumps and hits the trap, he should, well, be killed. So I'm gonna try and create something like this. Let's create an empty and let's name this vertical trap as, or even to be more specific, vertical spike trap. And then let's start by finding it. Okay, here it is, and I'm gonna add two children here, and it's gonna be big trap spikes and the block. And we have to, let's start by resetting their position so they are in the same place as the origin of the parent here. And I'm going to just move the spikes. Well, yeah, that actually blends in pretty nice, right? It's spiky enough, definitely. Okay, so what we can do after that is we can add a polygon, and so far we work with the rectangular collider, but we're gonna use polygon collider here. So let's search for polygon collider 2D, and then we have to edit it. And as you can see, you have here a list of points, right? And you can create additional paths for your polygon collider, and here are the points which can be manipulated either by changing those inputs here or by dragging here, but you can also click to add a new point. So we have to decide whether we would like, I think we should create the polygon that wraps around the whole, the both sprites. So let me position that here, drag this here. Basically we are creating the outline from our polygon collider to match our wonderful, let's add this here, to match our wonderful sprites, and then add a point and post it here, and another one here. Okay, So this is pretty good. We have our vertical spike trap, and here comes the new concept. I would assume that in our level we'll have multiple traps. So many game objects that have kind of the same behavior, but maybe a slight change in properties, like for example how far or how fast will they move. So I'm going to create a new folder and call this prefabs, and whenever you are creating reusable game objects, you're basically creating prefabs. And to create one, I can just click on that and drag it here, and now it will change into a prefab. And this is gonna be prefab instance, but now I can just spawn the same prefabs, right? And they will be basically the same. Let's see. Yeah, the order of the rendering is gonna be important here, but we'll handle that in a second. So now I can place many instances of that. One thing that I have to handle is, of course, a script for trap. So let's get to it. I'm gonna create a script, and this I will try to make a very general script, and I will try to add it so that it can be reusable. So yeah, let's just add a movement script. Oops. I'm gonna call this wrapped axis movement. Add this and let's start working on it. So I'm gonna need a few properties here. First gonna be how far from its starting position given trap should move. This is going to be serialized field, private, float, movement, offset, and I'm going to provide it with a value of 0.75 units, and then movement speed. So serialized field, private, float, movement speed. We'll set it to 0.1, and then few vectors that we'll need. So that's gonna be private vector free starting position or start position, private vector free end position, and private vector free movement direction. And that's gonna indicate, let's maybe add a comment. Oops. Indicates in what direction the prop is currently moving. And yeah, that's gonna be it for now. So let's go to awake, and the start position is going to be transform position, and position is going to be start position, and movement offset, right? Is this correct? Not really. Basically, I'm gonna assume that the trap is gonna move up if it's moving in vertical space, Yeah, and now it is correct. Then moving to our update, I'm just gonna create a function here to make it more descriptive. I'm gonna call this move up down, and I'm gonna call this here to make our trap move, make it roll, move up or down. Okay, so now we have to do some assumptions, right? We'll start by moving up, and then after reaching the highest possible point determined by the offset, we start moving down. So we have to check whether current position in our update is close enough to end position to start moving down. Basically, check whether we finished moving up or down, or whether we should actually keep on moving up. So if let's add another comment, should the trap keep moving up? So basically, if end position or in the y-axis is far enough from the current position, and I'm going to check 0.1f, and current move direction is equal to vector 3 up, then just to transform position at the vector up times time delta time times movement speed. You can fix the multiplication order to make it more performant, because you should firstly multiply the floats and then multiply by vector only once. Otherwise, you would multiply by vector 2 times, which is less proficient than multiplying by a vector once, as it is a bigger structure than a float. Okay, else, right? Have to else if yeah, this is the move up part of the code. Then we have to check, maybe let's move that here. Should we should the trap keep moving down? And this is if our transform position y minus start position y is bigger than 0.1f, the same value as above, and movement direction is vector 3 down. And in this case, yeah, just I would like to move that here, and in this case just move the game object down. So that's gonna be plus equals vector down. I could also do minus vector up, that would be the same, times time delta time times movement speed. Else means we are at the start or end point, meaning we are at the highest or at the lowest, and we should switch the movement direction. The movement direction is equal to check current movement direction is equal to vector down, so switch it to vector up. If no, switch it to vector down, and that's gonna switch the direction at the top or bottom. I have to get accustomed and really remember to comment my code, because I believe that's gonna help you and me both. Well, yeah, that should be enough to do the trick. Let's see whether that's going to work. So let's move here. We have this applied to both of our wonderful traps. Let's move it out of the way. And let's see. It seems as if that's not working. And didn't even compile, and I know this because we have those serialized fields which I don't have an access right now. That doesn't matter really. Let's start again. Yeah, let me try and reapply the script in that case. Remove component, and we can apply the overrides. Let's get rid of that for now, and let's try and add this one more time. Yes, and you can see it will happen from time to time. So yeah, I'm gonna just restart the Unity. I restarted the Unity, and of course sometimes, well, it happens. Just have to do it. Now we can see that the script is applied properly and the values are serialized, and here we have our trap. For now it does not interact with our player yet, but we can extend the functionality of our trap axis movement. So for once, change the movement speed, thankfully. Once I would like, for example, have a possibility to make the trap pause at the bottom for a while and then continue moving. So let's add just that. I'm gonna add a few things here. So that's gonna be serialized field, private, flow, movement pause in seconds, 1F. And we can also add a tooltip here saying set value to 0 to disable movement pausing. Yeah, okay, sounds good enough. So if that value is 0, will not pause at the bottom or at the top. Yep, word private bool. I'm going to create a flag that will indicate whether we should wait or not. And at the very start, I'm going to initialize it false. But should I? No, it's going to actually start with a false, I think. Okay, and here in our update, I'm going to just say if wait is true, do not move. And in my move up down, below that, I'm going to create a coroutine to actually stop the movement. So I'm going to do here, I'm going to set the wait to true because we're at the top or bottom, so we should wait here. And then I'm going to create a simple coroutine and call this private enumerator. It's to be generic. I'm going to call this wait. I'm just going to say yield, return yield, wait for seconds, when all in seconds. Yep. And after the wait, I'm going to set the wait back to false. So you can use that coroutine here by starting the coroutine wait. So the rest of the code is gonna execute as it should, and then after 2 seconds the wait's gonna be or 1 second I believe it's gonna be set false. So we can actually use those coroutines to perform some asynchronous tasks, right? Or do some stuff related to time. But I'm gonna add something else here. We have to have that modification running only if wait, how do we call that? Just movement pause. If movement pause in seconds is greater than 0, otherwise it makes no sense to wait for anything. So yeah, that should work. Let's see. And for any reason this is still not serializing, so let me restart Unity again and try to figure out what the problem is. Okay, so here we can see the movement pause in seconds property that we can adjust. So let's see how that works right now. So let's bump up the speed. It's gonna pause for 1 second and then keep on moving. So if I'm gonna change this to 0, now there's no pause in movement, and this is cool because we can do some tricky traps that will pause for a random amount of time that will throw our player off balance. So that's cool. Let me actually create another trap. So we have that as a base of our prefab, and we'd like to, for example, create another trap that would have the spikes placed on the horizontal axis. So I'm gonna grab this and drag it again to prefabs and then create a prefab variant. So I'm gonna rename that to be horizontal spike trap, and as you can see it still has a variant parent of vertical spike trap, meaning it will inherit all the game object components and their properties, right? So let's drag this and redesign it a little bit. Those wonderful spikes, I'm going to duplicate them and gonna call this trap spikes left, trap spikes right. Okay, and let's move them to the correct position. So I'm going to rotate this 90 degrees, take them and place them here, and also this is right, so they should be at the right side, right? Okay, so let's re-rotate them. I'm holding Control to rotate the stuff in the 0.5 increments, and then this, grab this, move it. Okay, let's move that. We would have to do that in the prefab. Maybe I could scale them to 0.9. 0.9, and this doesn't matter, but okay. Then let's move them just a tiny bit closer. Okay, this will do. But now we're using the very same script, and for now we're only able to use that script to move vertically. So let's actually change this. We open the script, and this is trap axis movement, and let's change that. So to do that, I'm gonna create a movement axis, X and Y. It's gonna be two values, and we're gonna add this as a serialized field. So movement axis, movement axis, movement axis. I believe this is how it should be named. Or maybe, why do you suggest that? Okay. And then it's going to be movement axis Y. Yeah, and then we have to adjust the end position because it's gonna change based on my movement axis. So here we have to check for the movement axis and say if the movement axis is Y, then we're gonna use vector up. Otherwise, we're gonna use vector 3 right to do the movement. Okay, that's fine. Here we're gonna create a simple if statement. Check if movement axis is equal to movement axis X. If so, we're gonna create a function called move left right, else keep on moving up and down. And this function is gonna be pretty much the same as the one we have in the up down. We just have to change a few things. So basically I can copy all of this and then change the axis. That's gonna be X, X, checking vector right. Here's gonna be right. Here is gonna be X and vector left, and here's gonna be vector left, and here we're gonna switch the direction, right, left, right, change the comments, keep moving right, move right, keep moving left, should have move left, switch the direction at the left was point left or right. Let's say and okay, and that should work. Let's see where it was. It looks like it is compiled, but well, it's only the it's only the inspector. I'm having some kind of problem with the compilation for now. Not really sure why this is happening. Maybe I should restart my computer, but I'll be back in a second to show you that it's working. And here you can see that we have that movement axis. as an option. So to make it work, here we have to switch to X. Here let's stick with Y and let's add movement offset set to, I don't know, 3. Okay. And then let's play. And did I screwed something up? This is moving in the Y, this is moving in the X. Yeah, of course, this should move in the Y direction and this should move in the X direction. And we should change the movement speed. Right, so let's try restarting that. This is vertical, so this is going to be Y and this is this, so it should be X. Try that again. Yeah, it's moving even between very slowly. Now it's better, so 0.1 is definitely too slow, should give it different value. But now we have the spikes moving in both directions. Cool. Yeah. Now we have to only do one thing that is left, and it is to actually kill our player whenever he collides with the trap. So let's actually add another tag, and I'm gonna create a trap tag. It's gonna be simple enough, and I'm gonna tag our wonderful objects and apply all. Oops, I didn't mean to. Let's get back to this. Trap axis movement, this is okay, the tag itself is okay. Let's go to prefabs. Yeah, and we have to change it here also, because these are the instances of the prefab. It's vertical, this is horizontal. Yes, it's all correct. So now with the tags added, I can go to my player manager. Oh, and also we have to make sure that we create is trigger here and here to make sure that we're not really interested in the collision. We're just interested in the information about whether we've hit the trap or not. And with that done, we can just go to our player manager, and here let's add another tag. So it's going to be private const string trap collider tag. It's going to be this trap, and I can just do this collider compare tag trap, and that should be enough to kill our player. And let's see. Yep, as you can see, now we have at least something to do in our game. That's gonna be avoiding our traps. Let me maybe get into time up and move that, or remove that even. And something crashed. Yeah, I'm definitely having some problems and I would have to restart my computer. So will that move? Maybe we should add tracking right to our game. So let's try this. We're going. Yeah, and now we're falling into the pit. But that should be it. Maybe just test it. Let's grab that horizontal spike and move it here to see whether collision with that will kill us too. And yeah, we will die. So yeah, this is kind of cool. We have our traps here. We can change their speed, and we can change their movement offset. Right, and now we can start working more on our level with those cool changes. Okay, yeah, so we have our traps. Maybe we should change that horizontal trap and actually give the user possibility to jump on it. That would be kind of cool, but we'll do this in the next video. So thank you for that, and I will see you in the next one. Goodbye.